Hello and welcome. I hope you are having a great day. In this video, we are going to understand equation of a hyperplane. First of all, let's understand what is a hyperplane. You hear this term a lot in machine learning. So hyperplane is nothing but say for example, if you have a two-dimensional space, right? So if you have a two-dimensional space, so if we have any line, say for example, this is a line, right? So it divides this 2D plane or 2D space into two parts. There's one part here, there's one part here. Okay. Similarly, if we have three dimensions and if we have a plane, okay, a paper, okay. So if you have this three-dimensional space, a room, okay, whatever, and if I have a cardboard or a plane kind of thing that spans for infinite dimensions, that will divide the three-dimensional space into two parts, right? So as the line divides a 2D plane, so the 2D is two dimension and the line is one dimensional, right? It has one dimension, only one dimension it moves. A 2D plane into, so a line divides a 2D space into two distinct parts. Similarly, a 2D plane, right, divides a 3D plane into two distinct parts. So we can keep on generalizing, so we cannot think or imagine beyond 3D. So if we have like n dimensional space, and if we have a n minus 1 dimensional, what do we call that? So that thing is called a hyperplane. So even this line in two dimensions, which is a one dimension, so this, for this two dimension, this line can be called a hyperplane. And for three dimensions, a two-dimensional plane will be hyperplane. And if you generalize it to n dimensions, so anything that divides the complete space into two distinct parts, that is a hyperplane. Okay, I hope the hyperplane understanding is clear. So this is also hyperplane. A plane is also hyperplane. So anything that divides the complete space into two distinct parts, this is a lower dimensional subspace. So this is a subspace which divides the complete space into two distinct parts. That's a simple hyperplane. So what is the definition of hyperplane? So let me write it formally. Hyperplane is nothing but a lower dimensional subspace. So this is a lower dimension because this plane is 2D xy and this has been divided into two parts. So this is a lower dimensional. This line is one dimension now. So this line is a hyperplane. So for a two dimensional, one dimension. For 3D, 2D. So for ND, n minus 1D. Or for D dimensions, D minus 1 dimensions. For D dimension space, we will have a hyperplane that is D minus 1 dimensions. Okay. So this is a lower dimensional subspace. Lower dimensional subspace that divides a space into two distinct parts. So now we understand what is a hyperplane. Okay. So even this line is a hyperplane. So let's understand a hyperplane with its simplest form and we'll generalize it to d dimensions or n dimensions, whatever. So we'll generalize it to two dimensions. So this line will run for infinite space and we'll divide this into two distinct parts. So what's the equation of a line? See this line only. What will be the equation of this? Say for example, if this is the theta, okay. Let me. So this is your theta, and this is the y-intercept, or this is called y-intercept. This is equal to say some constant c, and this is the x-axis, y-axis, right? So this is a simplified view of hyperplane. Okay, I'm just making you understand using this example, but the whole maths will follow from this understanding. You understand this, right? So I will not go into much details, but this will give you an intuition of how the equation of a hyperplane and all the terms will be defined. So we'll take this simple thing and we'll extend it and we'll understand the equation of hyperplane. At least the intuition of all these things will be understood, and the maths also will be very close to that. Okay, so that's what is the intent. So what will be, so this is theta y-intercept. So for theta, what will be the slope of this? So the slope of this is m. This is equal to tan theta. So what will be the equation of this line in terms of this intercept c and this slope? slope is equal to slope SLOPE, this is tan theta. So what do we write? Equation of a line. So we write y is equal to mx plus c, right? Equation of this line. So this is your, what is the slope of this line? This is positive, right? This is positive because as x is increasing, x increases on the right, y is also increasing. So the rate of change of y with respect to x is always positive. If x increases, then y also increases. So this slope is positive slope. What if I have equation of a line this way? So let me draw a dotted line, and let's say if we have another line like this, the other way around. Okay, so let me draw it this side only. Or let it be here. Okay, so this is our line, this dotted one. And let's come back. So what will be the equation of this line? This is the slope here will be positive. You know, the tan theta slope will be positive. So what is the slope of this line? This will be negative. Right, the direction in which, why is it negative? Because as you can see this line, right, it is going. So as x is increasing, x is moving towards right. So at this point, say for example at this point, say for example here, x, say this is x is 1. So y is having some corresponding value here on this line. But if when x is increasing on this side, y is decreasing, means the rate of change of y, delta y by delta x, this is negative. Simple, right? When x is increasing, y is decreasing. So that's why this slope, okay, this slope, so this theta will be something here, this is a bigger theta. So slope of this line is negative because the change, so as x increases, y is decreasing, and here in this direction for this line, as x is increasing, y is also increasing. So if x is here, y is here, so this is here, x increases, y also increases. So that's why the slope of this line is positive and the slope of this line is negative. I hope that is clear. Okay, these are the basics, just a revision of the basics. So what do we need for expressing an equation of a line? This is the intercept. Here then there will be some intercept, right? So we need two things. What are the two things? So in order to represent a line, we need two parameters, the slope m and the intercept on y-axis, the other axis, whatever. How this intercept is, how far it is from the origin. It can go from here also, right? So this distance gives me how far it is from the origin. It can go anywhere. It can be like in the positive direction, it can be in the negative direction, it can just pass from this here also. The line can go anywhere, right? I can have a line passing through the origin. I can have a line like this, then this my c will become negative. My intercept y will be negative here, right? But it just gives me how far it is from the origin, in the positive direction or negative direction, or if it is like it is on the origin itself. If it is passing through the origin, then it will be 0. So this is what this thing denotes, that how far it is from the origin and what is the slope or direction. So this direction is positive direction and this direction is negative direction. So I need two things, the direction of the line and the distance from origin, right? It is going in the positive direction or in the negative direction, and the distance from the origin, how far it is from the origin. I need these two parameters to represent a line. So let me write it down. So m is equal to slope, or this is equal to direction of the line, whether it is moving in the positive direction or it is coming down, it is going to the negative direction, okay? And the c is equal to your intercept on the y-axis, and this is equal to distance from origin, right? If I have just these two things, then I can represent a line which is a hyperplane in 2 dimension. It is dividing the space into 2 parts, right? So if we extend this logic now, similarly to represent a hyperplane in d dimensions, okay? So for example, if I have an okay, in d dimensions, now it will be like all mathematical because you cannot think beyond 3 dimensions. So that's why this maths becomes so helpful. So but if this concept is clear, okay, you need one direction of line, in which direction it is moving, and if you know the distance from the origin. I just need these two things. Similarly, I'll use these two things to represent the equation of a hyperplane. So similarly, to represent a hyperplane, I need, okay, so hyperplane in d dimensions, how it is given. So what is the equation? So equation of a hyperplane in d dimensions, so if I have d dimensions, will be, it is given by pi d. So this is the notation. This is equal to, so it is w1 x1 plus w2 x2. These are all the coefficients around all the dimensions, so on till wd xt plus distance from the origin, the constant. So here also y is equal to mx plus c. So this is giving me the direction. So these all parameters will be giving me the direction, right? Y by x, and this is the distance from the origin. So these are my w1 x1, sorry, w1 x1 plus w2 x2, and this is your distance from origin. So let's see. So why I can put it in vector notation now. So say for example my w is equal to, I'll put this thing w2 till wd. This is a d cross 1 vector, and my x is a vector representing all the dimensions x1 x2 till xt. This is also d cross 1 dimension. So how can I represent this? We have done a lot of linear algebra already, so we can say that the pi d is equal to w transpose x plus w naught. Okay, so this is a w transpose. So if I transpose this, okay, so let me write the w transpose also for you, so that you get the clear understanding. So it will be a w transpose look like. W transpose will be nothing but its row. This is a column vector. It will become w1, w2, like this till wd, and your x is your column vector. So the transpose of this is row. Now if I this is a multiplication. This is 1 cross d. This is d cross 1. So finally I'll get a scalar w. Okay, 1 cross 1, and this is a summation of all this. So I'll get w1 x1 plus w2 x2 till so on till w dxt, and I can represent this in a very concise format as w transpose x. This is capital X. This is your capital X. Okay, this is just notation. Okay, plus w naught vector. Okay, so this is your equation. Now let's understand. Let me put it here. So if I divide both the sides by the norm w2, okay, we have understood norm also. So what is the second norm? Is the Euclidean distance, that is square root of w1 square, w2 square, so on till wd square. This is your Euclidean norm. This is how it present. So if we divide both the sides by this, okay, so this equation, so the equation of this will be 0, right? This is equal to 0. So this is equal to 0 equation. So because y equal to mx plus c, so this pi d, okay, this is equal to 0. So this is the equation. Okay, so now let's divide both the sides. So this will be w transpose x by norm w plus w0 by norm w equal to 0. So what is this w transpose by norm w? What is this? So this is nothing but, if we divide, this is a vector, right? This is a vector. If I divide it by its length, will I not get the unit vector? Okay, so w transpose x, okay, here. So and if I divide the vector by its length, so I'll get a unit vector, right? This will be equal to a unit vector w of, this is a unit vector, means length 1. So whatever was the length, I divided by its length. So this vector had some length, I divided it by its length. So if I don't write anything, that's by default Euclidean. Okay, so now the vector has become one length. All the units are divided by its length. Okay, all the entries. So this will become w unit vector w x plus w naught by w equal to 0. And now if you see, so what is a unit vector? Unit vector is nothing but, it has magnitude 1 and it is just giving me the direction. So it has just direction. Okay, so now, and this was your first thing, this unit was your distance from origin, so the constant factor. So now we have presented this equation of hyperplane similar to what we had. So this W naught is nothing but your direction of hyperplane, and your W naught by norm of W. Okay, this one here is equal to distance from origin, and this is how we represent. Okay, this is the equation. This is the general equation, and now we have understood it using that this part, that W transpose, if we divide it, this is the unit vector which will give me the direction of the hyperplane. So here there are only two parts, this line, okay, is dividing into two subspace. So if I, this is two subspaces, right? So one space is towards origin and one space is away from origin. Whatever the space will be, it is dividing. One space will be towards origin unless until it is passing through the origin. Then the plane will be dividing, this line is dividing this into two spaces. One is towards the origin and one is away from origin. Those are the two spaces. Similarly, even if you take this line, it is one part is away from the origin and the other part is towards the origin. This is the origin. This is your origin. So that's what a plane will do. So it will divide in two parts. So the direction of this will be either, there can be in two directions, away from origin or towards the origin. So that will give the direction of the plane. And then the other unit that we need is how far it is from the origin in any dimensions. Okay, that's how you have to visualize. I need only these two things to represent any hyperplane. To represent any hyperplane, I need just a unit vector which will give me the direction of the hyperplane plus how far it is from the origin, and these two are sufficient to show me. Okay, so this is clear. Let's see what will be the direction from the origin. Sorry, distance from the origin. What will be the distance from origin? So let's draw it now. So now this, whatever we have done, let's draw the hyperplane. Say for example, this is my hyperplane. Okay, so this is my hyperplane, and let's say this is my origin. This is the origin O. Okay, and the direction of hyperplane is like this, in this direction. So this is your W unit vector. Okay, this is the direction of hyperplane. This is nothing but my pi d. This is the plane. Okay, and now if I have to find, so say there is any point x. Okay, so I have taken any point. This is x on the hyperplane. So what will be this distance? Okay, so my equation is W transpose x plus W naught equal to 0. That will be valid for any x on this hyperplane. And if I want to find, okay, what is the distance of this from origin then? So if I drop a perpendicular, is a perpendicular, okay, and this distance is the distance from origin. If this is x, say if this distance is, this is x here, so, and this is theta, so what will be this d? D will be equal to x cos theta, right? Simple. This is your hypotenuse, this is your base. So this will be your projection of this on this line. So this is the distance, this will be x cos theta. So what is the W transpose x? So anything, what is your any vector like u transpose v, this is equal to u dot v. We know that's the dot product, and this is also equal to distance of u, distance of v cos theta, right? So now we'll express this W transpose into that format. So this is equal to, this implies W. These are all nice. If I don't mention, sorry, if I don't mention anything, means that is the Euclidean now. Okay, that distance. So W's distance, length, x length, cos theta plus W0 equal to 0. And what do we want to find? This is, if this is x, distance of point is x, this is the distance is x. So you want to find what is x cos theta. So my x cos theta is equal to minus W by, okay, I brought this minus W and divided by this. So this is your distance, this is d, right? So this distance from origin is nothing of the hyperplane is nothing but is given by this minus w by the length of that length of the this w vector. In all the dimensions, the w will have all the values, right? So this is your distance of plane. And how it is written? So we write distance of plane from the origin. So this is origin to plane is equal to minus w naught by w. This is how we write it. Okay. And we saw that this is the direction of the hyperplane. So this can be either this side away from origin or towards the origin. Only these two directions it can have. This can be away from the origin or towards the origin, right? So two directions only we have seen this. So now so this is the distance from the origin. Now let's understand this. So again, so note 1, if hyperplane passes through origin, then what will be my w naught? If hyperplane passes through origin, then what will be my w naught equal to? That will be 0, because the distance from it is passing through origin. The plane is here itself. The hyperplane is passing through here, so this distance will become 0. No problem. Now there are some things. So if it is okay, so either what will be w naught? Either it can be 0, negative, or positive. So if w naught is negative, okay, that is negative, then the plane, what is the, so understand this, if this w naught is negative, which is here in this case, if both considering both the things are positive, if w naught is negative, then the plane is in the direction of my unit vector w. So I will define my unit vector w in certain way, right? So this is the direction of my unit vector, which is pointing away from the origin. The unit vector could have pointed this way also, because this is also perpendicular. The perpendicular can be in both the directions. This is also perpendicular, this is also perpendicular. My unit vector can have pointed this side also from here. But here in this case, my unit vector is pointing away from it. And if w naught, the distance, okay, the distance w naught by this is negative, then the origin is, okay, then the direction of, okay, the plane is in the direction of the unit vector, means this plane is in the direction of the unit vector, means this is on this side. If my unit vector would have been this side, then my plane would have been this side, okay, the other side of the origin. So if my distance, this distance is negative, then my plane will be in the direction of the unit vector, that is this. Sorry, I hope this is clear. We'll do a simple example, then you will get it. If this w naught is negative, then the direction of the plane is, okay, the plane is in the direction of the unit vector. So here in this case, this is in this side, so it is on the other side. And if, okay, so if w naught is negative, so let me write it down. So this is 2. If w naught is negative, then plane is in direction of unit vector, okay, with respect to origin. So my plane is in the direction of the unit vector, so that is in this side. If this was on this side, then plane would have been this side. And other way around is, if my w naught is greater than 0, that is positive, then the plane is in opposite direction of w naught with respect to origin. This is same direction if negative, and if it is positive, then this is in the opposite direction. Okay, I hope you get the point. Means if my w naught is positive and my unit vector is pointing this side, if my w naught is positive, okay, and my unit vector is pointing in this side, then my plane will be on the other side of the origin. Okay, if the origin is here, my plane, the same plane, would be on the same distance, but it will be on the other side of the origin. Okay, okay, let's do an example, simple. So let's consider a hyperplane in 2D, that is our line. So question. So let's consider a hyperplane in 2D. That is the most simplified view in 2D. That is a plane. So let line, so my pi d is equal to w transpose x plus w not equal to 0, and the unit vector w here I'm defining it as in the x direction. This is a 1 comma 0, so it is in the direction of x axis, positive direction x axis. Okay, that is how I have defined my unit vector. Okay, so now pointing along positive x axis, positive x axis. Okay, so my equation of the line will be so this is your 1x, so this is my line 1x plus 0. I say for example this is plus w naught equal to 0, or so this is my equation of line for example, or this can be written as x plus w naught equal to 0. This is my line's equation, simplest form for understanding, so that this will be very clear. So this is my equation of line. If this is like x1 x2, these are x1 x2 are dimensions, right? So here my x and y is there. So what will be this? So x plus w naught is my equation of line, and my unit vector is pointing in positive x axis direction. So what will be the case 1? So for example, my case 1 is w naught is less than 0, that is negative. Say for example, my w naught is equal to -5. Okay, so what will be my equation then? Then equation of line will be, so the line or plane, I'll just write pi d, is equal to x minus 5 equal to 0. This implies x equal to 5. This is my line. Where will this line be? Let's draw it. So this is your line. For example, 1 2 3 4 5 6 7, -1 -2 -3 -4 -5 -6, whatever. This is y, this is x, and say this is 1 2 3 4 5, -1 -2 -3 -4 -5, like this. And this is your origin, 0. And what is my unit vector? Unit vector is pointing here. This is 0 1. This is my unit vector. X is 1, y is 0. This is my unit vector. Okay, so now what will be the equation of line? X is equal to 5. What is the equation of line? X equal to 5. X equal to 5 is always x is 5 here. So this is the equation of the line. X equal to 5. Whatever, this is the line. This is your x equal to 5. So now tell me whatever theory we have done. Okay, what did we say? If w naught is negative, then the plane is in the same direction of unit vector with respect to origin. So my plane is in the same direction, that is towards positive axis with respect to origin. Means the plane is in the direction of positive x-axis here. If my w naught is negative. Okay, if that is the case. So this is my direction of x-axis, and the plane is also in the same direction with respect to origin. Both are in the same direction. That's what it means. And what will be the case 2? Say for example, case 2 when w naught is greater than 0, that is positive. This implies, say for example, my w naught is equal to 5. Then what will be my equation? Pi d, or the line's equation, same thing. That will be x plus 5 equal to 0. This implies x equal to -5. Where will that line pass from? Here. So this is your x is equal to -5. This is x equal to 5. This is your x equal to -5 line here, this line. So now what did it say? If w naught is positive, then the plane is in opposite direction of unit vector with respect to origin. So now you see, if now my plane, this w naught is 5, which is positive, and my unit vector is pointing towards the positive x-axis, but my plane is in the opposite direction with respect to the direction. So the plane should have been in the this direction of origin, but because this is positive, so it is in the opposite direction with the, okay, opposite direction of the unit vector with respect to the origin. So that's why my line has moved this side. I hope this is clear, the direction with respect to unit vectors and the w naught sign. Okay, this is the example which makes it very clear. This is very important. Okay. So this is when the unit vector's direction, this is in front of origin, this is in behind the origin, we can say that. Okay, and this should be make your direction very clear. So it has divided the plane into two parts. So that is the next part, let's discuss. So this is your importance of w naught, or the intercept distance from the origin. So the next thing what I'm talking discuss about is it has divided the whole plane into two parts, hyperplane. So that is called half space. So that is called half space. So the complete space is the full space. So this is dividing. So this was the complete space and it is divided into two spaces, 1 and 2. So these are two half spaces. Okay, and what will be the direction? Means what will be the value? There will be some more names for that. Let's see that. Okay, so hyperplane. So as I said, that pi d in d dimensions is pi d is d minus 1 dimensional in d dimensional space. If the space is d dimensional, then the hyperplane that we will have is one less dimension, d minus 1 dimension. Okay, for example, in 3D it will be 2D, and in 2D it will be 1D. So hyperplane divides the complete space into two half spaces. We have started with that. There are two distinct parts, and the two distinct parts are called two half spaces. Simple, right? One space you went into two. So one half space, two half space, one space, two half spaces. Simple. So what is my equation now? So let's draw the hyperplane again. Okay, so let me copy this hyperplane, or let me draw one again. So this is your hyperplane. Let me draw a green one. This is your hyperplane. Okay, this is your pi d. This is the direction of unit vector, direction in which it is there. This is your origin. Okay, and again, say for example, there is one. So there is a point x1 here. There's one point x1 here. Sorry. Wait, let it be here, x1. So if I have this line, if I want to see what is the distance of this line, so this is there, and if I keep extending this line, this will meet it somewhere here. Okay, and let's call this point as x1 dash, and then let's take the same thing, is 90 degree, the distance. So this is this distance we know. From what is the distance of the hyperplane from here? We have calculated that. So I'll just take the magnitude. So that will be w naught by w. That is the distance. We have calculated this already. Okay, so if this is the case, okay, so for any point x here, if any point x is there on the hyperplane, will this not satisfy the equation? So we can say w transpose x plus w naught equal to 0 for the pi d. If any point is on the plane, it should satisfy the equation. Now if I have to find, okay, what will be the equation with respect to this line here? So what will be the value of this if I put w transpose x1 plus w naught? Will it be positive or negative? What will it be? Will it be greater than 0 or less than 0? How will you find that out? Okay, so let's see. We know that, so see this distance. So there is x1 here, and the projection of this on the plane is x1 dash. So for x1 dash, we can say that this is on the, so this w transpose x1 dash plus w naught equal to 0. This we know, right? And if this is the distance from the origin, if you see here, right, if you project it here also, so if you see, this distance will be less than this distance, even this distance, w transpose this distance from the origin, this is O. Okay, so the distance of this point from the origin is less than this point x1 dash. This point distance, it is closer to the origin than this, because it okay. So if this is the case, so if I say the length of this, okay, so the length of this, that is the distance from origin, will be less than the length of this. Can we say that? So can I say that length of x1 will be length less than length of x1 dash. So this distance will be obviously less than this complete distance, because this is just extended and projected on the plane, right? And we know that if we multiply, so if I multiply W transpose into x1, okay, if I take the dot product, okay, of W transpose with x1 and add the sum, will it not be, I'll do the same operation on both the sides. Will this hold? I have just taken a W transpose here, W transpose, and plus W naught I have added for both of them on both the directions. And we know that, okay, so this will equate, because this is less than this is just magnitude. Everything is magnitude right here. So these are magnitudes, because this is like W x1 cos theta plus W is less than W x1 dash cos theta plus W naught. W naught is anyway, it's going to cancel out. This is positive, okay, and theta also, whatever be the sign, that will be the same sign, considering this is less than 90 degree. Okay, this is less than 90 degree, so this will be somewhere between 0 to 1, so this will also be positive. So if I multiply everything with positive, and this is like everything is positive, so I can write this equation. So we know that this part is equal to 0 because of this, because of x1 dash, it lies on the plane, right? So this part we can say this is 0. So what can we say about this point then? So we can say W transpose x1 plus W naught is less than 0, means it is negative. So can we say that this half space is negative half space? Similarly, if I had any point x2 here, okay, and if I have to compute the distance of this point from the origin, or what will be, if I put this on the equation, what will be its value? So if this is on this side of the hyperplane, this is negative, then if this is on this side, then obviously we'll get positive. If we follow similar steps, so if I follow similar steps, similarly I can write W transpose x2 plus W naught is greater than 0 or positive, right? And that's what we can say, that this is the negative half space and this is the positive half space. These are half spaces. This negative half space, this is half space. So this is a negative half space, this is your positive half space. That is what this is dividing. And how do we find out? So we did the maths and we found out which is towards the origin or opposite to the unit vector, that is your negative half space, and which is away from the origin, that is your positive half space. In the same direction of unit vector, so which is the part which is in the same direction of unit vector, that is your positive half space, and the part of the space which is in the opposite direction of the unit vector, that is your negative half space. Okay, so what is your positive and negative half space? So we write note that the positive half space is in same direction as unit vector W, and negative half space in opposite direction as W, unit vector. This is the unit vector, that is the direction of the hyperplane that we have decided. Okay, and this is very useful. So this, whatever we have discussed, right? So let's quickly do a revision, and this is very useful. This is used in, so what is the use cases, why have we studied this? So we will revisit this use, this, what is the uses, sorry, of this equation of hyperplane. So this will form as the foundation for doing logistic regression in machine learning, where we are doing classification, and then also this will be for SVM, support vector machines. So this lays on the foundation for these two. If you don't understand the equation of a hyperplane, understanding this will be very difficult. So this is the foundation for that. Okay, that's why it is very important. Let's do a quick revision. What did we study? So we understood that like any line, okay, a line is a hyperplane in 2 dimensions. So a hyperplane is nothing but a lower dimensional subspace that divides a space into two distinct parts. So in 2D, a line is a hyperplane because it is dividing in one less dimensions, and we generalized that when we found that for d dimensions, anything which is in d minus 1 dimension, that will be a hyperplane, and that will divide the space into two subspaces which are called half spaces. Okay, and that's what is a hyperplane. Sorry, it goes off. Okay, and we took a simple example. We started with a line. Any line can be represented as m slope, that is giving the direction of the line. Okay, whether it is positive or negative, and intercept, that is distance from the origin, how far it is from the origin. And using that concept, we derived the equation of the hyperplane also here. Okay, where did we do that? So here, sorry. So we found out that, so this is the distance from origin. So there, we found out that we divide everything so that there is a unit vector which has direction of hyperplane, which tells us whether it is towards the origin or away from origin, and there's a distance w naught, which is the distance from the origin. W naught divided by the norm of the vector, norm of w, that is w is the vector. Okay, second Euclidean distance. Okay, so that is there, and then we found out what is the distance of that hyperplane from the origin. So that came out to be minus w naught by norm of w, and this is the distance, and if we take the magnitude, this will be the magnitude of this absolute value. And then we found out that what is the where with respect to origin, and this minus w naught parameter, which is the distance from the origin parameter. Okay, where will my hyperplane lie given the direction of my unit vector? So if my unit vector, okay, it will start with this. If w naught is negative, then the plane is in the same direction of unit vector with respect to origin. Means if w naught is negative, then my plane is in the same direction as unit vector. So if unit vector is pointing away from this side origin or this side, then my plane will be on this side. Okay, and if w naught is positive, then my plane will be in the opposite direction of the unit vector. If unit vector is pointing this side, then my plane will be in this side, if w naught is positive. Okay, and we saw that with the help of a line example where my unit vector was pointing towards positive x-axis, and then we saw this, and then we saw the two half spaces, that we saw that equation that this distance will be less than any line which is projected, any line on this, any point on this line will follow this equation, and we saw that this is less than this, and we found out that any point which is in opposite direction of the unit vector in which direction it is pointing, that is your negative half space, and all the points or all the space that is pointing towards your unit vector, that is a positive half space, and we saw the calculation for that. And the usage is for logistic regression and support vector machines. That is what is hyperplane all about. So these concepts will be very helpful when we do these concepts. Okay, on that note, let's end the video. Thanks for watching this video. Have a great day ahead, and bye for now.